Hello friends, today's question: when a block of iron floats in the mercury at 0 degree centigrade, fraction K1 of its volume is submerged, while at temperature 60 degree centigrade, a fraction K2 is seen to be submerged. If the coefficient of volume expansion of the iron is gamma Fe and that of mercury is gamma Hg, then the ratio of K1 and K2 can be expressed as. So it is given that iron is floating in the mercury and the temperature of mercury in one case is 0 degree and in another case is 60 degree, and when it is 0 degree, the fraction K1 of the volume, it means if the volume is V, then the fraction of that volume which is given as K1 will be submerged at 0 degree. Similarly, the fraction of K2 is to be submerged at the temperature of 60 degree. So we have to find out what will be the ratio of K1 and K2. So in this case, excuse me, we have to find out, understand the concept of the floating. So let us first of all say understanding the floating condition. Understanding the floating condition. So we can say, in case of the floating condition, the weight of the displaced, in this case it is mercury, or in general we can say that is liquid, the weight of the displaced liquid is equal to the weight of the object. Here the object is iron block, and the liquid is mercury. Okay, so we can say that the weight of displaced liquid, and in this case it is a mercury, so let us rewrite it Hg, is equal to the weight of the object. Here object is iron, so let us call it as ferrous, Fe. So let us assume that volume of the block, volume of iron block is given as Vfe, and density of the block, iron block rather, density of iron block is, let us suppose, is given as rho Fe, and the density of mercury is given as rho Hg. Density of mercury, which is our Hg, is given as rho Hg. So there are two temperatures, 0 degree and 60 degree. So let us first of all find out the fractional relationship of the volume submerged at 0 degree. So we can say at 0 degree centigrade, fraction is given as K1. So we can say that K1, volume of our iron block, density of our mercury, 0 degree centigrade, will be equal to volume of iron multiplied by density of iron at 0 degree centigrade. Similarly, we can write at 60 degree centigrade, we get fraction is given as K2. So K2 is equal to volume of ferrous at 60 degree centigrade density of Hg at 60 degrees centigrade will be equal to volume of ferrous 60, and we get this as density of ferrous at 60 degrees centigrade. Okay. Now we also know that as the temperature is going to change, there will be expansion in the iron block as well as in the mercury. Okay. And that we can call as a volume expansion with temperature. Volume expansion with temperature. So like I said, that volume of iron and mercury changes with temperature due to thermal expansion. Thermal expansion. Therefore, we can find out the new volume at 60 degrees centigrade, and it can be related with the original volume at 0 degrees centigrade. So we can say the new volume at 60 degrees centigrade can be related to their original volume at 0 degrees centigrade using coefficient of thermal expansion. Using coefficient of thermal expansion, or sometimes it is also called as a volume expansion. Volume expansion. And in the question itself, it is given as coefficient of volume expansion for iron is gamma Fe, and that for mercury is gamma Hg. You can say for iron it is gamma Fe, and for mercury we have gamma Hg. So let us find out the relationship for the new volume at 60 degrees centigrade and for with their original volume at 0 degrees centigrade. You can say for Fe, volume at Fe at a temperature of 60 degree will be equal to volume of iron at 0 degrees centigrade 1 plus expansion coefficient of ferrous multiplied by temperature delta T. Initial temperature was 0, new temperature is 60, so delta T will be equal to 60. This is for ferrous, and similarly we can write for it mercury. We get VHg at 60 is equal to volume Hg at 0 1 plus coefficient expansion, that is gamma Hg, multiplied by delta T, which in this case is 60. Now we have to find out that how the density changes with respect to temperature. So let us say density change with respect to temperature. Density change with respect to temperature. and we know that the density changes inversely with respect to therefore we can say that the density for iron and mercury at 60 degrees centigrade are. So we can find out that density change with respect to temperature for iron, we can write it as Fe at 60 will be equal to density of Fe at 0 divided by 1 plus, and we have coefficient multiplied by 60, and from here we can find out the ratio that density at 0 and density at 60 will be equal to 1 plus gamma Fe multiplied by 60. Similarly, we can write the equation for Hg, mercury. For Hg, we have gamma Hg at 60 will be equal to gamma Hg at 0 divided by 1 plus coefficient expansion multiplied by 60, and this can be written as gamma Hg by 60 gamma Hg at 0 will be equal to 1 upon 1 plus, sorry, this is rho not gamma, gamma Hg multiplied by 60. Now we are going to find out the ratio of relation of K1 and K2. Relation between K1 and K2. Relation between K1 and K2. So we already know that this is our K1 and this is our K2. We are going to use these two equations. So let us call this equation number 1 and equation number 2. Along with this equation 1 and 2, we are going to use two more equations. Let us call this as equation number 3 and this as equation number 4. So using equation 1, 2, 3 and 4, using equation 1, 2, 3 and 4, we get K1, we have a volume of Fe and mercury density at 0 divided by K2, volume of Fe at 60, density of Hg at 60 is equal to volume of Fe and density of Fe at 0 divided by volume of Fe at 60 and density of Fe at 60. So here these two terms cancels out, so we get this as K1 multiplied by density of Hg at 0 divided by K2 multiplied by density of mercury at 60, and this will be equal to density of iron at 0 divided by density of iron at 60. Okay. So we can just make some adjustment here. So we get K1 upon K2 is equal to density of iron at 0 divided by density of iron at 60. This is one part of adjustment, and second part is our density of Hg upon 60 divided by density of Hg upon 0. So like I said, using equation 1, 2 and 3 and 4. So here using equation 3 and 4. Using equation 3 and 4. We can write that K1 upon K2 is equal to 1 plus gamma Fe multiplied by 60 divided by 1 plus gamma Hg multiplied by 60. So this is the ratio of K1 and K2. This is the ratio of K1 upon K2. And the option available to us, we can see that both the number are positive. So obviously B and C cannot be the option because here the sign is negative. So either A is there or D is there. So from the option available to us, we can say the ferrous is on the numerator. So therefore, the only option correct is our option number A. This is also not correct. Therefore, I can say that option A is the correct one. Option A is correct. This completes the question. Thank you.